Hello everyone, my name is Adil and today I will be teaching you about trigonometry in right triangles. First of all, let's look at this little fun word, even though it's not really a word, but So, what I have drawn here is the phrase SohCahToa. Now, what does this mean? Let's just look, I'll just box these two letters right after the S, the C, and the T. O means opposite. H means hypotenuse. And if you remember, in a right triangle, the hypotenuse, and imagine this is a right, I haven't exactly drawn this correctly, this side is the hypotenuse, and we'll just call that H. Yeah. And then A means adjacent. Now, what does adjacent mean? If I tell you let's call this side A and this side B. If I tell you to find the adjacent side to A, you would say it's B, because it is the side right next to A. Likewise, if I told you to find the adjacent side to B, you could say A, because it is right next to B. It is an adjacent side. Now that we know all of what these letters mean, what does the S and the C and the T mean? S stands for sine, and it is a function. So just to make that clear, I'll make it sine of x, where x is some value that we put on the horizontal part of the coordinate axes. C stands for cosine of x. We won't be going over the actual graphs today in this video, but I'd like to give you an idea of what these are. And this will just be very basic and pertain to right triangles. We have sine of x, cosine of x, and T stands for tangent of x. You'll learn what all these terms mean in a separate video. But for now, let's look at what these mean pertaining to right triangles. Now, if I have a triangle, right triangle mind you, let's just make it clear. This little symbol means that this angle is 90 degrees, thereby making this triangle a right triangle. Now, if we call this side A, and we call this side B, and I call this side C, and I call this angle to be D, and I call this angle to be E, let's look at some practice problems that we could do. Okay, so now let's look at what does it mean if I take the sine, what does it mean if I take the sine of angle D? Oh yes, and the input that we are giving to each of these trigonometric functions, trigonometric just as sine, cosine, tangent, and other functions that you will learn in a separate video, if we put whatever we put in as an input to any of these functions has to be either a degree or a radian. Now, we're not going to cover what that means in this video, but let's say let's just work in terms of variables here. If I tell you to find the sine of angle D, what does that mean? Now let's go back to our fun little word here, SohCahToa. After the S, which means sine, I've written OH. OH stands for opposite hypotenuse, right? Correct? So, if we look at angle D and we want opposite hypotenuse, I should clarify, this means opposite over hypotenuse. So, what this means is we take the side opposite to D, which is B, and we take the hypotenuse, which is C, and we put them over each other to divide them. So, sine of D is equal to B over C for a right triangle with these variables. Now, what does cosine of D mean? Cosine of D, we've written after the C here, AH, adjacent over hypotenuse. So, we take now what does adjacent mean? If you remember from earlier, it means right next to. So, if we take the side right next to D, which is A, and then put that over the hypotenuse, we'll have the cosine of that angle. So, that would be A over C. Now, finally, let's go over tangent of D. Tangent of D, we have OA, opposite over adjacent. So, let me just erase this so it's more clear. We're not getting confused with the arrows here. And this says E. I should make that a bit clearer. Okay, so if I tell you to take the tangent of D, then you would take the side opposite to the angle over the side adjacent to that angle. So, what is tangent of D then? It's simply B over A, right? So that's what all of these functions are equal to in a right triangle. You can use this little word here to help you with that. SohCahToa. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. Now, let's try a practice problem. Okay. So let's say that I have triangle this. Let's draw it a bit big. We set up a right triangle just like this. Now, let's say that this angle is 30 degrees. And let's say that this angle is 60 degrees. So we have a 30, 60, 90 triangle here. Now, if you've memorized your trig triangles, then this would be a pretty easy problem no matter what the sides are, but we don't want to worry about that for now. So it's okay if you don't know them. And we just want to practice using these functions here. So let's say that this side is, let's say 4. 4 with whatever unit you want to give it. Now, I want you to tell me, and you may pause the video here if you would like. Give me a second just to erase this. Now, I would like you to tell me, what is the sine of 30 degrees? Now, actually, hold on. I think I may not have given enough information here. Let's say that this may not be an actual possible triangle, but let's see here. Sine of 30. Okay, let's try this. I want you to tell me, what is the value of x? And try to use the sine function. You can pause the video here and see if you can get it. And again, this doesn't really have to be a possible triangle. I'm just making up numbers off the top of my head here. Okay. So, if you'd like to know the answer now, let's do this. So, if we take the sine of 30 degrees, from our little word here, we can tell that sine is opposite over hypotenuse. So sine of 30 degrees equals 7 over, actually, this is going to get really confusing for later lessons, so I'm just going to change these angles a little bit. Let's say that you're something like 44. Yeah, let's just say that you're 44 degrees. And if you would like to retry the problem, you may do so. Apologies for that. It's just 30, 60, 90 triangles, and me coming up with numbers is going to make you very confused for later lessons. Okay, so let's redo this with 44 degrees. Doesn't really matter what the angles are, but choosing 30 and 60 are kind of bad. Now, if we take sine of 44 degrees, we know that sine for a right triangle is opposite over hypotenuse. So we look here and we take the opposite side, which is 7, and we put it over x. Now, sine of 44 degrees is 7 over x. And if you know from fraction rules, we're going to rearrange this and get that x is equal to 7 over the sine of 44 degrees. Apologies for my terrible handwriting. I'm just using a mouse pad on a Mac, and yeah. So this is our answer. Now, what if I said use it using cosine? Well, it would be basically the same approach. We would just do cosine and take adjacent over hypotenuse. So you'd take the opposite, the adjacent, which is 4, the hypotenuse, which is x, and divide them. And we'd have the same thing happen here. X would equal, and imagine this d is just 44 degrees, because that's the angle we're taking here. X is equal to 4 over cosine of 44 degrees. So, that's how you do it for there. Now, perhaps the easiest way to do this is to take the tangent. So if we take tangent of 44 degrees, what is tangent? Opposite over adjacent. Actually, I'm stupid. That doesn't even have x in it. But let's say you wanted to take the tangent of 44 degrees. All you would do is take the opposite, 7, over the adjacent, 4. So So tangent of 44 degrees is 7/4. And that is how you can approach all right triangle problems. If you're given a side and an angle, most of the time you can find all of the other angles and sides simply using trigonometry. Now, if you were asked to find an actual angle and you weren't given any of the other two angles, then you might have to use some inverse trig functions, which you can learn in a separate video. But we're not dealing with that here. So that concludes our lesson on trig functions pertaining to right triangles. Thank you for watching, and I'll see you in a separate one.